Okay, so in this video, I wanted to dive a bit deeper into how actually variables are stored inside of a computer, inside of a memory. So let's get on with some basics of memory and how different type of data types are actually affecting and how different type of data types are actually being stored in a variable. So this is actually the agenda of the video. So let's get started. Um, so according to a few of my notes here, so what I'm trying to explain to you is variables. But as I've explained in my variables video, that the variables are some type of boxes which we give names to, and those boxes store different types of values. Like pretty like a straightforward analogy. Um, so let's get on with some of the basics of how computers work. So computers generally work with ones and zeros. So it's just one and zero, like light off and light on, anything that you can understand ones and zeros by. So there is a concept called a bit. A bit is just the one and the zero. These are called the bit. For example, we have numbers, 1, 2, 3, 4, 5, 6. These are what we call our numbers. The bits are just the state of on and off. That's it. These are bits in a computerized term. These are called bit or bits. So when we have 8-bit, we call that a byte. Okay, so a byte is you can think of a byte having like 8 different slots. I don't know how many. 1, 2, 3, 4, 5, 6, 7. So 8 different slots, and 8 different slots have a specific value in them, a specific bit in them. So one might be on, another might be off, and the next two would be on, and then we have one off, and the last three can be on. So this is entirely a byte, which consists of 1 0 1 1 0 1 1 1. So this is the way we the computers understand what is a byte. So this specific value is very unique, and that's why it is mapped to a specific number that we humans can understand. For example, these are called binary numbers. For example, if we want to as far as I know, the most basic binary numbers are the zero is for zero. I might be mistaken, but very basically, what we can represent, one is one. This is like binary. This is like normal number. And then when we have two, the two becomes because there's only one and zero, so now it becomes like this. And then three is just one and one. This becomes three, and four is just 1 0 0. This is four. So up until when? When does it end? So basically, we have a limit to that, which is a specific limit that programmers don't actually remember, but there is a specific value to each of the numbers as well as different characters. For example, a has a specific binary value, dot 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 dot. I don't know the specifics of a. Symbols have a specific binary value. So whatever we store in the variable gets stored as a binary value. So that's what I'm trying to pull, is actually the address of the variable. Okay, because we have this box, and this box has a value inside it, and we want to put the box in a specific location, right? Because we'll be having more and more boxes. So we need to have a storage shelf or a specific location. So that specific location is actually the address of the box in our analogy. But in a computer, so we also give the address of the box as binary. So there is this address, and it holds a value. The address of the box. The address of the box might be 1000, and the value it is storing can be like 42. And the more that we use the next variables, it can be like in the address number 1001. It can hold the age of 25 that we talked about. The next address can be 102. So these values. Mhm. So, so these are actually addresses represented in a human context, but then it gets translated into binary, and then the computers understand where is actually this specific variable is located, and then get the value from the variable, and then so on. so so next we have to understand different data types. So there are specific data types. For example, to go back to our analogy of the boxes, if we define a box which can hold numbers, then the box would actually hold only numbers. It cannot hold other things, for example, characters like ABCD, or symbols, or other type of data structures, which we haven't actually gone through what data structures are. But that specific variable or box can hold that specific type of value. If we defined a variable, for example, definitions of a variable is actually done in other programming languages such as Java and C, C++, which is a mandatory thing to do to actually define a variable and also define the type of data it actually stores. But in Python, it actually understands when you say that age, the variable age equals to 25, it actually understands this age variable is actually an int. It will actually hold an int value. So what is an int? Int is a short for integer. Integers are basically numbers, nothing else. And there are other things. For example, another variable can be name. and the name can be inspire. Right? And this actually, Python understands it as a string. What are strings? Why is it called strings? We can get into that. But strings are basically what we, like in normal terms, we call text. So there are specific variables that we use, that we have to define, that this specific variable will hold text and this specific variable will hold numbers. So normally this is a mandatory thing to do in C, C++, Java, and other type of programming languages. But in Python, it actually, the Python automatically understands. You might think that it is a very good thing of Python that you don't have to actually state the variable type, but actually down the line when you get, like, thousands and thousands of lines of code, this actually gets a very messy thing, and you get errors for not assigning the correct variable and dealing with some type of variables. So let's get down to why actually, like, assigning types of variables is important. Okay, so in our example, we had age again being 25, and what we can do in the following line is that we can have this age and we can add to it, and this will actually have the age. Come on, I'm writing the G before age being 26. 26. Okay, so we can add to it because this is here is a number. This is an integer. So integers can be added or removed. There's another type of numbers called floating points. For example, it can be like height. Height. I don't know. It's like 5'8". Like, it's not a foot thing, but you understand. Like, it can be 5.8. So this is not an integer because integers are considered whole numbers. This is what we call is a float. If I can write float. Floats are basically what in, like, in layman's terms we call decimal numbers. We call it float because there is a tiny little dot which floats in the numbers going backwards and forwards depending on, like, the calculation that we do. So that's why it's called a float, and this is called an integer. And both of these floats and integers, we can add to it, we can subtract to it, we can do all sorts of, like, complex calculations to it, like divide it and multiply it. However, when you deal with an integer, and when you, like, this is the age of 25, and then this is an integer that we are talking about, and you divide it by 3, and you get something like 21. That's 7. 20. Oh, that's 8 point. So that's 8 point something something something. So you normally in a calculator you would get something like this. However, when you do it using an integer, it only shows you just the 8 part, not the other parts, because it uh, calculates, it just uses it as a whole number. I cannot find the wording, but it treats it like a whole number. So it does not actually understand when it's dealing with integers. It does not understand that you have floating point numbers here and there. Whereas when you do, like, the same thing with the floating point numbers, it actually shows you what you have after the decimal point, well beyond it. So you have got the difference between floating points and the int number. So you can ask that why don't we use, like, decimal points everywhere, because decimal points can be used as integers as well, because we can have, like, float age 25. Then actually this will work in a few cases, because it will not actually show you as 25. It will not actually store as 25. It will store as 25.0. That is how it will store. And then there will be a difference in calculations down the line. It will not actually affect, but you don't want actually, like, your age being 25.0 or 25.3 or something. You just there's some numbers are just whole numbers, and that's how you have to deal with them. So that's why you use, like, floating point numbers, and sometimes you use the integer numbers. Okay, cool. And the next type is what Python actually, I don't actually remember using specifically this one in Python, but what I'm trying to represent is characters. Characters, or in short, it's called char. There's a bracket. So in C, C++, you will be obviously, like, you would be familiar with char. Basically, what it writes about, like, how we write it is as char. And for example, maybe you are defining a grade, which you are saying this is A. So you are defining a character. The character, as we have discussed before, it is stored as a specific binary value, which I'm just writing at random. This is not the binary value for A, but this is how it is being stored. And when you store it in a variable called grade, it has, for example, an address. For example, the address is 2000, and it has a value. For example, this is the value, and it maps to the letter capital A. That's how characters are being saved in memory. And there are floating points, there are Boolean values. There's another type of data type, which is called a Boolean, which is basically the bits that we talked about. It's just stores information like true or false. It just holds two information, like one of the two. It's either true or false. It can be like 1 or 0. It can be on or off, whatever, however you want to call it. It's just white, black. So the most basic way we actually deal with Boolean values is the true and the false. So when we write true, we know that the true value is actually stored in the Boolean variable. The false is false. Maybe you can understand it by 0 and 1, but there's no lying type of true. It's just it's important when we will discuss about conditionals. When we will say look, 1 is less than 20, So what is it? Is this true or this false? This specific statement, is it true or false? Then we have defined, yes, this is a true statement, and this, then we can do for the calculations. So conditionals are very important in this, as Primigan actually said, that programming is just if statements. So yeah, that's that. So we have discussed variables, we've discussed the different data types. What few different data types are actually left? The next thing what I wanted to talk about was string. Which we discussed as string being like just normal text. But why is it actually called string? Because string is actually a string of characters. For example, when we have the name equals, for example, Tom. So Tom consists of 1, 2, 3 characters. And then how Tom is stored in memory is that we have the addresses. For example, it is stored in memory number 5000, and in the memory number 5000, the letter T is stored in memory number 5001, the letter small o stored 5002, memory number 5002 is the small m, and we have another small memory which is actually signifies the end of the variable, because it can go on, because in the memory, if there's in memory number 5003 there is maybe another character, the computer might not understand where this actual variable is ending from. So there can be like maybe in 499 there can be a starting value which actually signifies the start of the variable and end of the variable. So this is how a text, like, the bigger the text, the bigger the variable gets, and the bigger memory it takes. So why is it called a string? Because it's just a string of characters. So when you have Tom, is just a string of characters which actually connects all of the characters together with a string, and then it presents you the end product, and that's how the name string is actually being used. We don't actually think about it like this. Okay, moving on to lists and arrays, but in Python it's normally called lists, and other programming languages you might hear arrays. So let's just form a list like I don't know, numbers. And in Python we use the the solid brackets, the third brackets, and we have a bunch of numbers like 1, 3, and 5, and 9, the odd numbers, and we have this. So the numbers are actually stored in a similar. Each number is stored in a different address of the RAM or the memory, and it is being taken out like we do in string. So not we are not going to get into more into RAM sorry, into arrays at the moment, but we will get to it when we can. It's a very important concept, but we will go through it later. So we are generally done with all of the essential data structures. There are also dictionaries, which I think I should go through. So dictionary or rees. Dictionary is actually not a specific list. One thing about a list that I would like to add is that the list does not generally have to store the same variables, like the numbers that I've given examples. The list in Python can be different things, like one item of the list can be a number, the second item of the list can be a string, or a third item of the list can be another list. So that there can be lists within a list, and that is a very important concept coming up when we will deal with neural networks and stuff. But yeah, that's about lists. But dictionary is generally what you understand as a dictionary is that it maps two things as one. So you can just have one variable, like dictionary variable, which actually holds all of the information for an individual. For example, like me. For example, I have this variable called my name, which is Zubair. And this is a dictionary. And dictionaries are started and ended in Python. We use squarely brackets. So a dictionary is actually formed by key value pairs. So there's key and there's values. So there's you have seen dictionaries. So there's this one word and another thing which explains that specific word. So you have this key, which is that specific word, and the explanation of the word is actually the value. So the key maps to the value. So these are actually cannot be the same. So, and there should not be same two keys inside of the dictionary. This is something else. So for example, I can have age being a key, and I forgot how. Okay, this, yeah, being 25. I'm not 25. And then comma, then another field in the dictionary, because the dictionary is long. For example, first name, Zubair, comma, and then occupation, engineer, comma, dot, 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 dot. You can see, so just one single variable can actually hold a lot of different variables. Yes, of course, you can call this as variables. You just have to know how to call them up, which we'll see in the future videos. But this is what the dictionary is doing. Dictionary is a very large, considered as a very large variables, because it can hold multiple different types of variables inside of it. So that's it actually for explaining all of the data types. I'm going to clear this layer and then move on to the next part of this series. So I'm see you there.